Electromagnetic relays. These relays are constructed with electrical, mechanical and magnetic components, and have operating coil and mechanical contacts. Therefore, when the coil gets activated by a supply system, these mechanical contacts gets opened or closed. DC and AC relays. Both AC and DC relays work on the same principle as electromagnetic induction, but the construction is somewhat differentiated and also depends on the application for which these relays are selected. DC relays are employed with a freewheeling diode to de-energize the coil, and the AC relays uses laminated cores to prevent eddy current losses. Attraction-type electromagnetic relays. These relays can work with both AC and DC supply and attract a metal bar or a piece of metal when power is supplied to the coil. This can be a plunger being drawn towards the solenoid or an armature being attracted towards the poles of an electromagnet as shown in the figure. These relays don't have any time delays, so these are used for instantaneous operation. Induction-type relays. These are used as protective relays in AC systems alone and are usable with DC systems. The actuating force for contacts movement is developed by a moving conductor that may be a disc or a cup, through the interaction of electromagnetic fluxes due to fault currents. These are of several types like shaded pole, watt-hour and induction cup structures and are mostly used as directional relays in power system protection and also for high-speed switching operation applications. Magnetic latching relays. These relays use permanent magnet or parts with a high remittance to remain the armature at the same point as the coil is electrified when the coil power source is taken away. Solid-state relays. Solid-state uses solid-state components to perform the switching operation without moving any parts. Since the control energy required is much lower compared with the output power to be controlled by this relay, that results the power gain higher when compared to the electromagnetic relays. These are of different types: reed relay coupled SSR, transformer coupled SSR, photo-coupled SSR, and so on. The above figure shows a photo-coupled SSR where the control signal is applied by LED and it is detected by a photosensitive semiconductor device. The output from this photodetector is used to trigger the gate of TRIAC or SCR that switches the load. Hybrid relays. These relays are composed of electromagnetic relays and electronic components. Usually, the input part contains the electronic circuitry that performs rectification and the other control functions, and the output part include electromagnetic relay. Thermal relay. These relays are based on the effects of heat, which means the rise in the ambient temperature from the limit directs the contacts to switch from one position to other. These are mainly used in motor protection and consist of bimetallic elements like temperature sensors as well as control elements. Thermal overload relays are the best examples of these relays. Reed relay. Reed relays consist of a pair of magnetic strips also called as reed that is sealed within a glass tube. This reed acts as both an armature and a contact blade. The magnetic field applied to the coil is wrapped around this tube that makes these reeds move so that switching operation is performed. Relays are also available with different pin configurations like 3-pin, 4-pin and 5-pin relays. The ways in which these relays are operated is shown in the below figure. Switching contacts can be SPST, SPDT, DPST and DPDT types. Some of the relays are normally open NO type and the other are normally